Today we are going to discuss lipids. Here the book reference, Bruice, 3rd edition. Lipid is a kind of organic compound found in the living organism, and as we know this is insoluble in water but soluble in an organic solvent, for instance ether, benzene, acetone, chloroform, etc. Lipid is also synonymous with fat, but also includes phospholipids, sterols, etc. if we consider the composition of lipids. In case of chemical structure, lipid mainly composed of glycerol plus fatty acids. Here we go the conventional lipids reaction. Glycerol reacts with 3 fatty acids and from the triglyceride kind of lipids. Here the OH of glycerol and the hydrogen from fatty acid, they react to leave the water and the triglyceride form during reaction of this glycerol and fatty acids. Lipids are mainly categorized into 3 types: simple lipids, complex lipids, and precursor or derived lipids. Let's discuss about simple lipids. Fats and oils. As just we had seen, triglycerides. Fatty acid ester with glycerol. We sometimes also say triacyl glycerol. B. Waxes. Fatty acid esters of long chain monohydroxy alcohols. Cetyl palmitate as an example. Complex lipids. A. Phospholipids contain phosphate group like glycerol phospholipid, alcohol in glycerol, for example phosphatidylcholine. B. Glycolipids contain fatty acid, sphingosine and carbohydrate. Other complex lipids such as sulfolipids, aminolipids, lipoproteins. Number 3. Precursor and derived proteins. Fatty acid, alcohols and aldehydes. And we also have miscellaneous category of lipids, where sometimes we will see fat soluble vitamins like A, D, E, K, carotenoids, steroids, some cholesterol, steroid hormones, bile salts, etc. In this lecture, we will be little studying here fatty acids, triglycerides, phospholipids, soap and detergents that we call saponification, the preparation of detergent that we always use, and functions, and little bit of about problems. As we all know that excessive triglyceride or cholesterol creates our heart disease, little bit. And I also want to mention here that this lecture is kind of made for the organic chemistry student. If you are a biochemistry student, this lecture can be helpful partially, but maybe you need to learn more about the biochemical and biological action and mechanism for lipids. Fatty acids. What are the fatty acids? Fatty acids are long-chain carboxylic acids found in nature. You can see here CH3, and if we consider the structure, one end will have methyl and another end will have COOH group, and in between the CH2 parenthesis N, that means the carbon chain ranges from 12 to 24. and mostly we will see an even number carbon. Fatty acids are categorized into saturated fatty acid and unsaturated fatty acid. Saturated fatty acid which doesn't contain any double bond, and unsaturated fatty acids contain double bond. For our daily cooking and daily life, whatever the oil we use for cooking, normally it's better if we can select the unsaturated, because saturated are a single bond and it's very stable to not easy to break down. That's why this type of fat can long time store into our body, and that is not actually helpful too much if we consider the health issues. So we just saw the structure and fatty acids categorized into saturated and unsaturated. Now let's talk about the organic acids. Chain of carbon with hydrogen attached that has an acid group at one end and methyl group at other end, and this is a kind of structure. As we have just learned that saturated fatty acid doesn't contain any double bond. So carbon chain filled with hydrogen atom, no carbon-carbon double bonds. Saturated fats such as if we consider triglyceride containing 3 saturated fatty acid such as animal fats and tropical oils. Animal fat, for example butter, lard, and the tropical oils, for example palm or coconut oil. Also it appears solid at room temperature. If sometimes we cook the red meat, especially the long time cooking, we can see the yellow color fat floating, and if we keep in the room temperature or lower temperature, you can collect those fats. So those are actually the saturated fatty acid. And we also know the butter, coconut, that all can be solid at room temperature or low temperature. Here we go, the example of fatty acid, saturated fatty acid. You can see here stearic acid 18 carbon. So one end start with methyl group, and then 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, and one with methyl and one end with acid. So total 18 carbon saturated fatty acid. Another is, if we want to simplify the fatty acid structure, maybe we don't need to write too much like that. We can write as a methyl CH2 ring. So both structure are same, and this structure collect from here, though actually this is originated from the textbook Bruice. Yeah, but just for acknowledgement I'm mentioning here. Unsaturated fatty acid. Unsaturated carbon chains lack some hydrogens, and as a result we see the double bond. Mono unsaturated fat and polyunsaturated fat. Monounsaturated fat, for example triglyceride, contain fatty acid with one double bond. For example canola and olive oil are example of. Polyunsaturated fat. Triglyceride containing a high percent of fatty acid with more than one double bond, that is corn, sunflower, I think it will be sunflower, soybean, sunflower oil, and fish. And this type of oils appear liquid at room temperature. Here we can see the example of monounsaturated fatty acid and polyunsaturated fatty acid. Oleic acid 18 carbon, we have here the double bond because of lacking of the hydrogen atom. on these 2 carbon. Here we have linoleic acid 18 carbon, but we will see more than one double bond. So there are 2 positions between 2 carbon lacking of hydrogen. That's why this is polyunsaturated, and the name of this unsaturated fatty acid is linoleic fatty acid, unsaturated or polyunsaturated fatty acid. Unsaturated fatty acids example, we know the location of double bonds. Omega number. Omega number, what is the omega number related to this unsaturated fatty acid? Omega number refers to the position of the double bond nearest the methyl end of the carbon chain. So if we have the double bond, nearest to the methyl bond, in that case we will number, and then we will say like 3, 4, 5 omega, and then we will say the fatty acid. That's we are trying to see here, that the methyl end of the carbon chain, like omega 3 fatty acid, omega 6 fatty acid, etc. So we see here 1, 2, 3. Omega 3 and omega 6 fatty acid. So 3 position carbon bear the, with double bond, and here 6 number carbon with the double bond. The example of omega 3 and omega 6 fatty acid. What are the difference between saturated and unsaturated fatty acid? I think we have already now learned and studied that what are the basic differences between saturated and unsaturated. Let's have a look here. Saturated fats found mostly in animals. Unsaturated fat found mostly in vegetables. Saturated fats solid at room temperature. Unsaturated fats liquid at room temperature. For example, saturated fat butter, unsaturated fat olive oil. Fatty acid chains are straight as they don't have any double bond. Fatty acid chains are bent in some places and also contain the double bonds, one or more. Fatty acid substances called cholesterol is usually found together with polysaturated fats. Too much polysaturated fats and cholesterol in the diet may cause coronary heart disease, as just in the beginning I told that. Now you don't need to be looking to the different dietitians recommendations, doctor or YouTube lecture. So many people are lecturing so many things, but if you know the science behind it, then you can take your decision that what you should eat and what you shouldn't. I think from this simple difference and little bit of study about the lipid fat, now you know that why the fats or animal fats are recommended to avoid or eat in not in larger amount, I mean eat minimum amount. You can see the reason, because this type of stable fats, as I just mentioned earlier, that it takes long time to come out from the body. As a result, this type of fat always store in our body, and that long term intake of this type of fat create different types of health complications, including coronary heart disease. Saturated fats tightly packed clog arteries as atherosclerosis. Because of double band, as I said, polyunsaturated fats do not pack well, like building a wall with a brick. As I said, the unsaturated fatty acids are comparatively less stable, and they cannot pack tightly like saturated. And that's why irregular shaped object unsaturated. Yes, so that's why if we eat unsaturated fat, that is good for our health. Plant fats are much higher in PUFAs than animal fats. Yeah, that's a purified unsaturated fatty acid. So that's why we should choose the plant fats than the animal fats in our daily food habit or in our daily food, food lists. Triglycerides, fats and oils. Predominant form of fat in foods and major storage form of fat in the body. Yeah, when fat is stored into our body, they mainly store as a triglyceride. Structure. Triglycerides are composed of 3 fatty acids plus glycerol. We have seen in the beginning also. Triglycerides, simple triglyceride and mixed triglycerides. Simple triglyceride if the 3 fatty acid component of a triglyceride are same. For example, tripalmitin, the example just we show. See. Mixed triglyceride contain 2 or 3 different fatty acid components. Palmito-oleostearin, for example. Liquid triglycerides are called oils. Yes, we know. Solid or semi-solid form of triglyceride are fat. Phospholipids. It's very simple when lipids contain phosphate group. Are similar to triglyceride except the terminal hydroxyl group you can see here. Except the terminal hydroxyl group, terminal OH group is esterified by phosphoric acid. That means it contains 2 fatty acids. Cephalin, lecithin are example of phospholipid. So the difference between cephalin and lecithin, here we could see the amino 3 hydrogen is replaced by the 3 methyl group. So if you have a phospholipid with 3 methyl group in the 3 chain of with the phosphoric acid position, this is lecithin or phosphatidylcholine. And if you have not replaced by the methyl group, then this is phosphatidyl ethanol amine or cephalin. Soaps and detergent. Soap. We can see here saponification, how we make a soap. So fat or oil when react with the base. So sodium or potassium salt or fatty acid known as soap. Consequently, the hydrolysis of an ester in a basic solution is called saponification. So this reaction is called actually the saponification. That means the way we produce or we manufacture soap. So this is actually fat or oil. I mean the salt of fats or oil. Okay, that's we can how say. See here the soap formation, chemical reaction or saponification, whatever you say. So here we have the triglyceride or fat. Still we already learned CH2O, COOR, COR, CH, yeah, COOR2, CH2, COOR3. And this R1, R2 and R3 we have, but here we can see the CH2O. Here it will be broken. So here OH will join to H will join here OH, and this sodium will come here COONA. So that means the OH group comes here and COONA, 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 see R1, R2, R3. These three soap molecules. So that means 1 molecules of triglyceride react with 3 molecules of sodium hydroxide, produce glycerol and 3 soap molecules. Function or biological importance of lipids. Fatty acids. Metabolic fuel, obviously they give us energy, component of several other classes of lipids. Triglyceride, main storage form of fatty acids and chemical energy. Phospholipid. Components of membrane, we know that, sources of arachidonic acid, inositol, IP3, inositol triphosphate, and triglyceride DAC for signal transaction. That's really important for our um, body biological system and signaling. Sphingolipids, components of membrane lymph in signal transaction. So that means fatty acid, lipids are also have important biological function into our body. Continue. Cholesterol, component of membrane and precursor of bile salts and steroid hormone. So in our body, if we need to have the bile salt or steroid hormone enough, we need cholesterol, because cholesterol works as a precursor. Bile salts. Bile salts helps lipid digestion and absorption, main product of cholesterol metabolism. Steroid hormones. Intracellular signals that regulate gene expression in target cell. So here also have the role of steroid hormone in signaling and regulating gene expression. Eicosanoids, regulators of physiological and immunological functions and local hormones. So eicosanoids, prostaglandin, thromboxanes, leukotrienes, etc. And as we know, we have two types of vitamins, water soluble and fat soluble. So vitamin A, D, E, K, sometimes we call ADIC. These are the fat soluble vitamins, and as we know that each and every vitamin how important and are crucial for our different body performance, like vision, calcium metabolism, antioxidant, blood coagulation. So for those purpose, the vitamin A is really very crucial. Here we go some summary or what type of the multiple choice question we may have if we study this chapter. Again, I'm telling that this chapter I made for one of my semesters student who had a organic chemistry, organic chemistry 1, and so they don't need the detail how to synthesize, how the fat break down into energy, or how each and every metabolism or the works into our body. We don't need at this purpose. So if you need the details, you can let me know, I can make, and also this is enough for the organic chemistry beginner students. Here we have some multiple choice question. Which term best describes the compound CH3 CH224 COOR2 CH229 CH3? This is a kind of wax, because wax are the very high molecular weight ester formed from long chain carboxylic acid and chain of alcohol we have here. The common name for a C16 straight chain saturated fatty acid, C16 palmitic. Which statement is not true about prostaglandin? They are found in all body tissue, correct. They regulate many physiological response, correct. They all have 5-membered ring, correct. Prostaglandins are made from arachidonic acid, this is also true. Non-steroidal anti-inflammatory drugs, NSAID, increase, no. Actually, NSAID decrease production of prostaglandin. When prostaglandin concentration high into our body, we feel pain and sometimes also the result of fever. So NSAID, the aspirin, Napa, or different types of NSAID we have that actually decrease, their mechanism of action just based on decreasing prostaglandin, so that we can feel free and we can get rid of pain. So that was all about the lipid. If it helps, let me know if you have any comment there.